On the board, you're going to see that there are equations involving the modulus symbol. What we're going to do is we're going to unpack how we handle equations containing modulus. And I'll give you a hint, it's actually not particularly hard. Now, if we have a look over here, we have the modulus of 2x plus 7, and we know it's always going to be equal to 5. Now, imagine the modulus was not there. What values could come out of 2x plus 7? So ignore that, ignore that. What values do you reckon could come out of there?
Anything?
Anything really. It could be positive or it could be negative, couldn't it? So what we do when we're trying to solve these is we are allowed to unwrap the modulus symbol, where the consequence is we have a plus or minus 7. Now, because you've got plus or minus 7, you're going to get two conditions. First condition is 2x plus 7 equals 7, or you're going to find that 2x plus 7 equals minus 7. Doing the calculations here, this is going to be 2x equals 0, therefore x equals 0. Moving across over to here, if you do this, the 7s are going to stack to give you negative 14, 2x, so therefore x is going to be negative 7. Hence, x is going to be 0 or it's going to be minus 7. Now, one way to verify whether that's true or not is if you draw your attention to the board, we can plug this left-hand side and the right-hand side into the calculator, and it's just like we're in year 10 again, and we look for the points of intersection. So we know that the right-hand side is 7, the left-hand side is going to be options, numeric, absolute, and we simply type in 2x, x, 2x plus 7, bracket, just auto it, I guess. Zoom it out. The window up. We'll go negative 3. You know, we'll go 10. Okay, so you can see that it's intersecting at 7 and 0, or minus 7 and 0. So can we see how that answer is working there? You can do it analytically, like shown on the board, or you can do it graphically, shown on the calculator. All right, up the ante. B. How many modulus symbols do we have? 2. Too many. Let's take it to 0. How do you think we deal with this when we've got two modulus symbols? Pick one side to sacrifice.
Sacrifice the right one.
X plus 1 goes from modulus to parentheses. 2x minus 3 goes from modulus to parentheses. Which side do you want to sacrifice, Isaac?
The right one.
The right one. You only need to plus or minus one of the sides. Doing this, we split into two equations. The first equation is x plus 1 equals 2x take 3. The second condition we get is x plus 1 equals negative 2x take 3, which expands out to minus 2x plus 3. Solving this, we're going to move our x's to the left, so that will give us minus x. Constants to the right, that will give us minus 4. Hence, x is going to be 4. Or on the converse, we're going to get x's to the left, that's 3 x's. Constants to the right, that's going to be 2. X is going to be 2 over 3. Therefore, x equals 4 or 2 over 3. And of course, if we go over to our calculators, oops, we can type this in. So go back, we type in modulus of x plus 1. Then it's going to be modulus of, oops, 2x minus 3. We will turn the first two off so it doesn't get in the way. And how many points of intersection do we expect, Nick? 2. So it's going to be...
Well, I thought it was linear functions, so
one there, one there. Do they agree?
yeah, I agree.
2 over 3 and 4.
3 and 4.
Nice and easy, isn't it?
Yeah, no, this is some year 10.
Alright. I will give you a bit of a bamboozle now. I'll throw you a curveball and I'll see if you can do it because this is too easy.
Oh, way too easy.
Way too easy. So easy, you're very confident. And so was I. Until I ate some humble pie.
Man, I think it's time for you. I
didn't die, I got better.
Maybe last test.
Okay. What about these guys?
Yeah, they
What about these guys?
get served up with their pie. They're just too cooked.
Okay.
Way too cooked in the pie.
I'll take half the pie over a cooked pie. Over the pie. Yeah, that's basically the...
No, you're.
That's bottom percentile.
Yeah, but I'm there.
If you split it 50-50, if you split the class in 50-50, then you're in the bottom percentile. So
That's true.
Okay, guys, here we go. Could you do this analytically for me? As I'm going, I want you to do it exactly what I've shown you.
What? No sacrificial lambs here.
Modulus of x plus 2 is equal to 2x plus 1. I mean, this should be straightforward enough.
Wait, what did you do now?
Are we about to see that this is like, what is it? Something. I feel like we're about to like showing that this is not right.
How's that alright?
Or it's just an alternate.
That's what we were asking ourselves today in the math office. How can this not be right? We didn't think of the bigger picture here. So I see you have got your answer, Madden.
I feel like you made the wrong side of sacrificial labor in this case.
Does it matter which side we pick?
No, it doesn't.
I'd say it would if you went into modulus.
Go the opposite way to what I just did.
So,
The right side might have been the left side to do in this case. Did you get a result, Brad?
yeah.
Same? Okay, here's the thing. Madden is verifying that the sides don't matter right now. And I can confirm, but yeah, probably. Okay, did we do it on our calculators though?
No.
No. So let's turn these functions off and let's put it in. It's going to be the absolute value of was x plus 2. The next one was 2x plus 1. We're going to set our V window to, we assert it's going to be between, let's go to -3 and 3.
Look, I feel like there's no reason to show this. It's not. It's not. It's in the top of something.
Where's our intersections?
1 and 3. What?
Not one. Just one.
Just one.
Just one. You can't have negative genius.
Oh.
No, we can have one for sure.
Yeah.
But why?
She's only going.
Why not? That's the question. Why are we not allowed to have that answer? When in the past we've had plenty of negatives.
Yeah, that's actually that's interesting.
This got Prasad and I quite bothered today.
Is he the smart?
He's the one who used to teach the engineers back home.
Listen, he gets up on this, but he can solve this massive induction code.
He doesn't come up to brief on the induction, he just does it.
Oh, right.
But we both got stuck on this. Now, the question is, what assumption are we making when we split these two equations off? Think of the modulus here. What are we assuming about this modulus?
It has to be positive.
In this case here, we're assuming that x plus 2 is greater than or equal to 0, are we not? Solve for x. Our assumption is that x plus 2 is greater than 0, so therefore our assumption is that x is greater than or equal to minus 2. In this instance here, is this met?
Yes, greater.
Condition is met. Conversely, what's our condition over here?
I don't know.
Assuming that we're going to go x plus 2 is less than 0 because we're going for the negative case. X is going to be less than minus 2.
Why?
Is the condition because when we make this negative, we make the assertion that when we state that we're putting the negative symbol here, we're making the assertion that x plus 2 is less than 0 because we're going for the negative case. Do you see? Now, if we are making the assertion that this is less than 2, we infer that x must be less than minus 2. But the question is the answer we're getting out of here valid?
It's not.
No, it's outside of our domain. So therefore,
Why are we making the assumption x is greater than negative 2?
because we're unwinding our modulus. We unwind the modulus by making two assumptions. One, where it's larger or equal to 0. The other, where it's less. When it is less, everything's reflected back into the positives again. When it's more than, we just don't do anything with it. So this is the key step that we're missing before. Do you remember when I was saying when you have the modulus of x and you're trying to get rid of it, you just sub in positive x and then you sub in negative x? This is the step that doesn't say in the textbook. This is the step we just forget about. But that's why we're making an assertion that the expression that we're pulling out of the modulus is either greater than or it's less than. It doesn't matter what side you pick, even on this one here, your domains will still match up with the answers you get. But that is why when we look at the graphical interpretation, we're missing that x equals minus 1 solution because it's not in our domain and there's no need to go any further than that orange writing on the right here. Does that make sense?
Well, do you still have to figure out that x is not in the domain?
It's
So you still have to do the step, you just don't.
you can do it if you want.
But how do you know that x is gonna...
Calculator.
Oh.
The quickest way, just do it in the calculator first to see if how many solutions you're expecting.
Like graph or just solve in?
Actually no. If you want, you can skip this step here
Whoa.
and there and say
Is it fair?
Oh my god.
Count. P of K. Using P of K.
Nah, using calc. So you can state, if the examiner gave you like 10 marks for that, it's the examiner's fault for giving too many marks. But if you can do something with a calculator and it doesn't state you can't, CT4.
Oh, so if it's like a 4-mark question, it's say, solve this, and you use a calc, it should be like 1 mark, but you deserve a 4.
That's the examiner's problem if they messed up.
Well, okay.
Use your calculator whenever you can. But what we're looking at here is y. So the underneath of what we're doing. Does that make sense?
Interesting. Basically.
Alright.
So you can take off the whole negative 1.
Yeah, you can.
How often is it that the examiner messes up like that though?
Rarely. If it's me, it's never.
Oh, I like that.
You're not an examiner, are you?
For the lower years.
Oh.
Okay. So what I recommend, go back and do the early questions from F.1, 2, and then when you get to 3, towards the end you'll see stuff like that. That's why we're subbing in the positive x and negative x. We're making an assertion of when it's negative and when it's positive, and that's a direct application there.
I just moved it to the right page.